So now let me see the whole thing graphically. Okay, so what I have discussed in the form of diagram, in the form of mathematical equation. Now let me conclude the topics in terms of graphical. That is graphically how we can understand how the values are changes, the applied force, the normal reaction, the frictional force, how these values are changes with respect to theta. Okay, so as I have said that if we increase the angle of inclination theta, then all the values of frictional force and the normal reaction and the applied force will be changed. So initially, when there is an object like this, we have some forces along this direction, we have mg sin theta along this direction, we have F, and along this direction we have normal reaction, along this direction we have mg cos theta. So this kind of situations are there. Now if we want to denote all these things graphically, if we want to show the whole picture graphically, then what we will have to do, we have to plot n versus theta, capital F, that is applied force versus theta, as well as the frictional force versus theta, or you can say the limiting frictional force versus theta in the same graph. If we draw these three graphs on the same plane, then we can understand how these values varies when we will vary the theta. Okay, so what are the forces? Let me see. Here the applied force F is equal to mg sin theta. So obviously this F will vary proportional to sin theta. Similarly, we have the frictional force. What will be the limiting frictional force? If we talk it as limiting frictional force, then obviously limiting frictional force, then it will be alpha. So now initially let me take this as just FL is equal in terms of theta. Let me take it first in terms of theta. Okay, so this FL will be mu n and n will be mg cos theta. N will be what? Mg cos theta. So you can see here that FL is proportional to cos theta and n is also proportional to cos theta, but the maximum value and f of FL and n, that is different. Here the maximum value is mu mg and here the maximum value is mg, and mu is obviously less than 1. So the maximum value of FL will obviously less than n. So on the graph FL, the maximum value of FL, we have to write under the maximum value of n, because this mu is less than 1. So FL will obviously be less than n. Now you can see this FL and n is varying with cos theta. So what will be the graph of cos theta? We know the graph of cos theta like this. If we talk about y versus x, and if you want to plot y is equal to cos x, then the graph will be like this, you know, and this is what pi by 2, and we have to draw the graph up to pi by 2. Why? Because this theta will vary maximum from 0 to pi by 2. Then the purpose of our inclination will be same. If we again incline the plane in this side, then the whole thing will be converted along this side. So our purpose here, the relevant value, or you can say the value that we need, actually theta, we can vary the theta actually from 0 to pi by 2. So we have to draw the graph from here to here. So obviously if you talk about this FL and n, they will vary in same fashion and with cos theta, and they will vary like this, or this will vary like this. So they have to be 0, like this. At the same point, they have to meet at the same point, and that is nothing but obviously pi by 2. Okay, and now if we increase theta, then what will happen? If we increase theta, then mg sin theta will increase. And when this f will be FL, that is the limiting condition, when this FL will be equal to mg sin theta, and mg sin theta is nothing but the applied force. So if we increase theta, the applied force will vary according to sin theta, that is proportional to sin theta. And for a particular value of theta, that is when the applied force will increase. As theta increase, the applied force mg sin theta will increase, and it will attain a value when this theta will be alpha, and at that situation this f will be fl. So if we increase theta, your mg sin theta will increase up to what? Up to pi by 2, because you know your graph of sin x like this. So this is our pi by 2. If this is y versus x graph, y is equal to sin x, y is equal to sin x graph. So your value will increase up to what? Up to pi by 2. Up to pi by 2. So your value will be increased. If you increase theta, then mg sin theta, that is capital F, this graph. We have already done this two graph an and fl versus theta, but we have to now draw this graph f versus theta. And how this f is varying? This f is varying like mg sin theta, that is proportional to sin theta, that is graph will be like this. At theta is equal to 0, obviously f is equal to 0, there is no applied force when the surface has no inclination. Now as we increase theta, this f will increase. This f will increase, and as this f will increase, it will be increasing like this, then it will touch the graph of FL versus theta. And when this applied force and FL will touch each other, then what will happen? This theta will be alpha. When this applied force, if you increase theta, the applied force will be increasing, then it will be equal to the frictional force, that is FL. And at that situation, the value of theta will obviously be equal to alpha. Okay, because this is the angle of repose. And your value of sin theta, your value of f will obviously be increased to this theta is equal to alpha. Now what will happen? Now it will be increased. It will be increased up to this point. Okay, up to this point, that is pi by 2. So if we draw a line like this, so it will again increase to this point, and its maximum value will obviously mg. Okay, and n have the same maximum value mg, so it have to be equal. So it have to touch on that point. Okay, so let me draw this graph again. So it must be touched the graph at that point, and in that case this will be theta is equal to alpha. Okay, because you know the maximum value of n. Okay, the maximum value of n here is mg, and the maximum value of f here is also mg, because maximum value of sin theta is 1 and maximum value of cos theta is also 1. So the maximum value of f and n will be same, that is mg. So it have to be touch this point, because at this point the theta is equal to pi by 2 and sin will have its maximum value, and obviously the n graph will start from here, because at theta is equal to 0, you can see n is equal to mg, and obviously FL will be less than FL, because this mu is less than 1. So this is the graph. In the same graph, if we plot on the same graph, okay, same paper, then you can understand how these three forces are varies as we increase theta. And in a situation at theta is equal to alpha, in a situation, then FL is equal to obviously capital F. So this is the graph of capital F versus theta. Okay, so this is how you can explain the thing. Okay, thank you.